We already saw in common drain the voltage gain is approximately equals to 1 when we consider the ideal situation like our output impedance is very high or G naught is very low. Now it is very good to know why exactly when this situation arises, why exactly the voltage gain is 1. Intuitively, we need to see whether we are able to answer it not. So basically, if you look at the circuit, uh, basically this is our common drain circuit. The claim is basically when we don't have that output resistance and we have the ideal situation like here the current source is ideal. So this voltage, the incremental voltage over here is same as the incremental voltage over here. So V in is same as the V out, or V out is same as the V in. But why it is so? Because see, this is the current source and it depends on the transconductance and the gate to source voltage. Okay. Now, as it is there is no R naught and there is no resistance for I naught. Okay. So this current, this incremental current doesn't find any path to flow, right? So in that case, this current Gm times VGS has to be 0, and Gm is not 0. We know this is the, otherwise there is no operation of the transistor. It means a transistor is dead. So that VGS has to be 0. If VGS is 0, it means this Vi is same as the V out, or V out is same as the Vi. So this is the logical way of explaining why in a common drain configuration the voltage gain is 1 ideally.